Hi everyone, welcome to another Godot tutorial. Today I'm going to be adding a player character. So the first thing we want to do, I have created a little scene here, a little platformer scene where the player character will exist. You can create something simpler, I just needed a few platforms, and you can see how you can make something like this in my previous video on auto tiling. But the idea is that once you have your auto tiling set up, you can just click and drag. Um, so, what do we need? First up, I'm going to create a new scene. This new scene is going to be our player. I'm just going to call this player like so, and let's save it. You could save it in the main directory, or you can save it into a file such as, well, a folder such as resources, something like that. I'll just move these right here. There you go, it's a bit more organized that way. So, in order to have a player, we're going to want him to move. In Godot, for things to move, you're going to need to add a kinematic body 2D, since that gives you a lot of functions that allow that movement, I mean. So inside of kinematic body 2D, you'll notice we have a little warning here. This node has no shape, so it can't collide. So you just type in shape, collision shape 2D, and then we have another warning. A shape must be provided for collision shape 2D to function. The shape you can add in the inspector right here. Shape is going to be new rectangle shape 2D. Okay, so these are the basics. One final thing, very important, you would like to be able to see your player character. So what we are going to do in the Pixel Adventure 1 pack that we downloaded, we have characters. So you can pick any one of these. I'm going to go with Ninja Frog, and I'm going to click and drag the idle 32 by 32 PNG into my assets. Okay, so now we have this. We need to add an animated sprite since we have a sprite sheet. So we have animated sprite. In the inspector right here, we have frames. So we want to add some new sprite frames. And then, once we've done that, we want to click on this, the sprite frames that we have just made. And then you have a little button here, add frames from a sprite sheet, which is what we have right now, assets, and we select the sprite sheet. Let me zoom in for you. So you see that we have 11 sprites. 11 sprites right here, and it is separated into a grid. Now this grid is currently not correct because we have 32 by 32, and we want each of these to be one cell that we can add. So horizontal divisions are going to be, 11. Let me click somewhere else, and you see how it divided it into 11 equal chunks. And vertical divisions are, we just need one. And then we just click away. Okay, so it should look like this. Horizontal 11, vertical 1, size 32 pixels by 32 pixels. Then you want to select all of these, and you want to add frames, add 11 frames. There you go. So now we have our character right here. I'm going to move my animated sprite to be on top of the collision shape 2D, well, below it in this case, just so I can see the collision shape and how it fits with the character. And I am going to move both of them by clicking them and then pressing the up arrow key a couple of times until they're right here above the origin point. So do that for the collision shape as well. Okay, so you see this transparent blue box. What is it? This is our character's hitbox. So, oops. So whenever we are going to be colliding with an object, this is what will detect, the collision itself. And we can resize that. I think it would be a smoother feel if it was smaller than this, maybe something like this. And then a little bit shorter, something like that, let's say. That's what I'm gonna do for my game. Okay, you know what, maybe a bit. Okay, it doesn't like that. Doesn't like it when I hold Alt, that's fine. Maybe something like this even. Either way, it's gonna be above the ground. You'll see in a bit. Okay, so one mistake that you could make. Animated sprite, you could have for some reason put it outside of the kinematic body. Why is that a problem? If you put it outside of the kinematic body 2D, your kinematic body 2D is what will move along with the collision shape. So if this moves and this isn't inside it, this will stay in the same place, and you will not see the changes in your game being reflected later on when we add the movement. So make sure that the animated sprite node is inside of the kinematic body 2D node. The same for the collision shape 2D. You want this to be the parent of both of them. All right, so we now have our player. And we go back to our world, or however you decided to name your scene. We want to add our player into this. We can do that by right-clicking on our Node 2D at the very top, Instant Child Scene, and then we select our player, not TSCN. You'll only see this if you saved it. If you didn't save it, go back here, Control S, and save it wherever you want. Could be in a resources folder, could be anywhere else. Okay, and now we see our player. So this is a fine spawning position for the player, but we can move him around. You can click on him right here in the node tree, and then you can click on move mode, or you can just press W like I did, and then you can just move him around the world. I'm gonna put him right here. Right, so one more thing that it would be nice to add. A camera. With a camera, we will be able to decide what will be shown to the screen when we press F5 or play up here. So let's play the project. You might see this. No main scene has ever been defined. Select one. Let's select the current one, which is going to be world.tscn. And let's see what we will get. Okay, so as you can see, our camera did not work, even though we have defined it. Why? Because I forgot something very important. This current right here in your inspector, it needs to be ticked on. That way it knows that the main camera is going to be the one we just created, the camera 2D. So now if we press F5 again, there we go. Right, so you might be noticing one more issue. When we resize the window, our camera also expands. So we see more of the world. And there is nothing, so that's kind of counterintuitive. How do we change that? This is done in the project settings. So top left, right next to scene, project settings, and we are looking for display. So display window, and here you have the width and height of your view, well, your camera. For a pixel game, 320 by 180 is ideal. And as you can see, when I move this, the purple border became smaller. And that purple border is our camera view. Okay, so let us try this. And we will still have the issue, but I just want you to see what will happen in this case. All right, so our camera is smaller. We maximize this. Once again, camera is not yet scaling with the window. Or well, yeah, not scaling with the window. So to make that change, you go in the same place, display window, scroll to the bottom, you have stretch, mode, let's do 2D, aspect, let's do keep. Okay, another thing you might want to change, test width and test height. So you saw how I have to resize the window to maybe to be bigger, to be smaller, whatever suits my needs. But with this, we can just set this, press F5, and it will be this height and width. And I clicked and dragged, and I changed it, but it's fine. Let's try that again. You see 1280 by 720, and you see that our game has been scaled up. Now we can maximize this. We don't see more of the world. Our assets just get scaled up to fit the current window. So we are going back to our player. Now for the fun part. Now we're going to make him move. So right here, in our kinematic body 2D, we want to click right here on this attach a new or existing script to the selected node. Click this, leave everything to its default. We don't really care. We can erase all of these, or you can keep it. Wouldn't really change anything either way. But what we are interested in is right here in the function underscore process delta. So this will be running every single frame, and this is where our main player logic will sit. Let's do something simple. So first we want to define a velocity. And the velocity is going to be the strength in which our character moves in a specific direction. It will be of type vector 2, and by default it will be 0. So this is just an x and a y coordinate, and it will look something like this, right? Obviously you don't type that, because Godot will not recognize it. But yeah, to make our player move, we have a handy function called move and slide. And we are also going to store the value into our initial velocity variable. So move and slide, the parameter will be our velocity. So as of right now, we have not defined any direction. Our character will not move because it's currently at both x is 0 and y is 0. So let's add a gravity, and let's make that 1,000. Right? So to move in the y-axis, we want our player to fall. Falling would be an increase in the y-axis, right? Because it starts counting from 0, 0. The top left of the screen is 0, 0. The bottom, in our case, let's say our screen is 720 pixels high. The very bottom is 720. The middle would be 360, and so on. So in order to go down, we would need to increase. In order to go up, we would need to decrease. Okay, so velocity y, see, like I said, it has an x and a y variable. Well, in this case, I believe it would be called a property. So we want to make that, we want to increment that by gravity times delta. So we've done this. Let's see what will happen. Our player should be going down when we play the scene. Okay, and there you go. If you've set everything correctly, when your player goes down, he should just collide with your tiles. So ideally, we want our player character to move left, right, up, and so on. Right now, it's just going to be left, right, and up. But later on, you might want more. We go into project settings again. Right here, by default, you'll be in general, I believe. You go into input map. You have an action right here at the very top. Let's add a move left. Let's add a move right. Let's add a jump. So move left, you will see these at the very bottom if it has not scrolled down automatically for you. Move left, we want left arrow key. We also want, I'm clicking on the little plus by the way, to add another key, a key. Okay, move right, we add another key, right key, and also the D key. And then to jump, we press, let's say W, and then we can also press space. Okay, so now we have those configured, but how does it help us? We want our player to move. For that, we're going to be creating a move vector variable right here. It's going to be of type vector2, 0, just like our velocity. We're going to have an x and y direction. And we want, what do we want? We want the move vector x to be changed based on which key we are holding. So there are three possible outcomes here. It's going to be 1, it's going to be -1, or it's going to be 0. Depending on which of these it is, we will either move left, right, or not at all, right? So to decide that, we're going to need to look for a method, getActionStrength. So move right is the key that we defined for right presses, D presses, right there in the project options. And then we want to subtract from this input getActionStrength move left, right? Okay, I don't know why I added variable here. We do not want that. It will break everything. How does this help us? So I told you that there would be 3 outcomes, 1, 0, and -1. This is what gives us the outcome. This is what will change our move vector x. How does it work? getActionStrength is going to give you a value between 0 and 1 if you are pressing the key. If you're not pressing the key, it gives you 0. If you are pressing the key, it's going to give you 1. So if we're pressing the right key, this will be 1. If we're not pressing the left key, this will be 0. 1 minus 0, that's going to be 1. And let's say we want to go right. So we would like our velocity of x, so the strength in which we are moving to in the x direction in either way. Let's make a acceleration variable right here, and let's give it 1,000. How about that? We want to multiply acceleration times delta, and this is the magic part, times move vector x. So if move vector x is positive, we will be moving right. I think it's easier to understand if you look at it this way. But if it is negative, we will move left. So when is it going to be negative? When getActionStrength is active. Because if we're holding the left key, this will be 1. But since we're subtracting it, it will turn, move vector x will be -1. So this acceleration will move us in the opposite direction. Okay, so let us try it. Right now it will be very slow because I did a little something which I wasn't supposed to. I simply assigned it when I wanted to use a different operator right here. The plus equals, so plus equals is just velocity x equals velocity x times acceleration times delta. Well, actually, not times, but plus acceleration times delta times move vector x. So these two statements are equivalent. We just increment over the previous value. Okay, so now it should be a little bit better. We will be going fast, but it should be a little better. See? We are sliding left and right, left and right. And this is a bit problematic because it does not get reset. Once you click either left or right, you will keep on sliding in that direction, depending on the intensity and how long you've held it for. Could be cool for some games, but this isn't what we're looking for now. To fix that, I want to check if move vector x is 0. So move vector x being 0 would mean that we are not pressing either movement key, so we should not be moving. And if we should not be moving, we should be going from our current velocity to 0. And to do that, we need to use a function called lerp. It stands for linear interpolation. So you have 3 parameters here, from, to, and the weight. So from is going to be our initial value, so velocity x. To is going to be 0 because we want to stop moving, right? We want velocity x, so the strength in which we move in a given direction to be non-existent, 0. We want to stop moving, right? And then weights. So this is the how fast we're going to get to that value. So let's set that to 0.10. So what does it mean? If our velocity of x is 100 and our goal is 0, 0.10 is the steps in which it will take every single frame to get to that point. So if we are at 1, next frame we're going to be at 0.9, next frame 0.8, next frame 0.7, and so on. So if we were to set that to 0.2, and we would be from 1 to 0.8, 0.6, and so on. But as you can see, it works. So we accelerate, and then we decelerate. We come to a halt whenever we are not pressing the movement buttons. I think that looks pretty okay. So, there's one more problem. As you can see, as we have set it right now, we can accelerate forever. So the longer we hold the right key, the faster we're going to go because we're adding to the previous value of velocity x. And to change that, we want velocity x to be limited. We can limit it by using a function called clamp. So clamp is going to be our main value. The minimum. What is our minimum going to be? Let's say that our minimum is going to be a variable called run speed. And let's make that 125. I think 125 feels good. So the minimum is run speed, but it needs to be in the negative direction, right? Because we can go both left and right. If we're going left, we want the lowest possible value to be minus 125. If we're going right, we want it to be plus 125. Right? So let's try that again. It should feel a little better. Hopefully. It's a little slow. It's a little slow. You can always increase it if for some reason you don't like any of these variables, values. You know, how about 250? How about 250? It really is a lot of tweaking until it feels right to you. I like 250. 250 feels nice to me. It doesn't feel too slow. It doesn't feel too fast. But as you can see, I'm holding down the keys and I'm not going supersonic in either direction. So that is our horizontal movement done. But obviously for a platformer, you have platforms, and to get to them, you're going to need some vertical movement. How do you do that? So just like you have a move vector x, you will have a move vector y. And what you could do is you could do pretty much input get action strength and jump is the key we defined. But since this gives you a value from 0 to 1, you would like for it to be negative. So we're going to multiply by -1. Why? Because if we're jumping, we would like to go up, and up is the negative direction. If the lowest point is 720, and we are currently at 500, to go to 300, we would need to subtract. Right. So now, if move vector y is less than 0, then we want the velocity y of our player to be equal to move vector y times, and let's say variable jump strength. Let's make that 300. I think that might be nice. Times jump strength. Let's see how that works for us. Okay, I mean, we are jumping. We are jumping. If you're following along, you might be noticing an issue. Our jumping varies and is very limitless. So we hold it, we fly away. It's quite funny. We can change that. It is not a difficult change. We can just add, well, we can just check first. And is on floor. This is on floor is a function that checks whether the kinematic body 2D is currently touching the ground. Let's run that, see what happens. It completely broke it. There is a reason for this. It is because we currently don't have an up direction. We have not defined it. So it could check if we are on the floor, but it doesn't know what the floor is, which is problematic. So to fix that, right here, move and slide, let me type in vector2 up. And vector2 up is the equivalent of 0 and then -1. Right? X is 0, y is -1. Okay. So now that you have made this, you can hold down your up key and you can jump to your heart's content, as long as you are satisfied. We want to add another functionality though, because as of right now, our player's jump is fixed. So regardless of how long we press the up key for, we are always going to have, well, a jump strength of 300, which we don't want. We would like our player to have a bit more control. This is also done in a simple way, let's say, but we are going to have to change quite a few things. So input get action strength jump. This doesn't really work for us because we want to only press the jump key once. To do that, we'll use something else. Input is action pressed. But actually, is action just pressed is what we want, because is action pressed checks constantly if it is pressed, and is action just pressed checks only once. So is action just pressed, jump. It shows you right here that this is a Boolean, so we cannot multiply by a Boolean, so we need to convert this into something that we can actually work with. So if it is true, well, if the Boolean is true, we want our variable to be -1. And this is the shorthand version of an if statement. So -1 if it is true, else we're gonna just leave it at 0. And I won't play it for you right now because this does exactly the same thing, except you can no longer jump around while holding your up key. As fun as that was. Now we want to do a little something else. We want to change the way the gravity works. So while we are not holding the up key and we are in the air, we want to fall faster. That means our jumps would be shorter. But if we are in the air and we are holding the up key, we will be jumping to our full speed. So our gravity is right down here. So right here, we want to be checking if the player is in the air. We do that with velocity y less than 0, because if velocity y is less than 0, that means it's in the negative. If it's in the negative, we're going up. If it's in positive, we're going down. We also want to check and input is action pressed jump. I want that in parentheses, otherwise it won't work. And we want this to be equal to false. Okay, so currently the idea is if we're in the air and we are not holding the jump key, we want our gravity to be multiplied. So we want our gravity to be stronger so we fall faster. So let's do variable gravity multiplier. That is free. And we would like to change the way our gravity works about now. We're going to be copying this right here because it's going to work the same way, except we're going to multiply by our gravity multiplier. And then if velocity is, well, in any other circumstance, we just want our gravity to be normal. But if we are in the air specifically, and we are not holding the up key, we want it to be increased, yes. And we would also like to increase our jump strength by a little bit, maybe to 500, to see how that would work, since we also want to, well, we do want to be able to get to our platforms. Okay, so I'm holding it down, full jump strength, I tap it, lower jump strength. The jump is still a little high. We can change that if we really feel like it. Let's do 350, just so it's the max jump. Okay, that's not quite there. 425, let's say. If it is 425, okay, that seems like enough. If the jumping feels bad to you, try increasing the gravity. To me, this feels okay. Nothing too outstanding, but you know what? He jumps. That's all for now. Tune into the next video if you want to see me add the camera to the scene and have it actually track the player. It's going to be pretty cool. Bye bye.